Today I want to talk about factoring quadratic expressions. We have talked about multiplying binomials. By the way, this is called a binomial because it has two terms. Terms are separated by plus and minus signs. So 2x is a term, 3 is a term. That makes this a binomial. So here we're multiplying binomials. One of the methods we used was putting it in a box. So 2x plus 3 times x minus 4. So I'm going to multiply all the parts. I get 2x squared, a positive 3x, a negative 8x, and a minus 12. Then you combine like terms, so I can combine the x's. So when I do that, I'm going to have 2x squared, negative 8x plus 3x is a minus 5x, and then we have a minus 12. So that was one of the methods we used. We also talked about FOIL. You can use the method that you prefer. So what if we need to go the other way? What if we needed to factor something like 2x squared plus 9x plus 4? And when I say factor, we need to make our answer look like this. This would be factored form. It could have a plus, it could have a minus, but we need to be able to factor it. And so we have to figure out what to do. Well, we can still use the idea of the box. The 2x squared is going to end up in this part, and the 4 is going to end up in this part. But what we don't know is how many x's go in each of these two boxes, because these two boxes will be the x's, and we don't know that. So one of the things we're going to talk about, there's different factoring methods, and we'll get back to the one of that previous problem. So the first thing you're going to do is ask yourself, is there a greatest common factor, or a GCF? So you're going to look at each term. Here's a 5x squared, here's a 2x. Well, notice I can't take a number out. 5 and 2 do not have a common factor, but an x squared and an x, I can take out an x. So notice what I say. If so, use the distributive property backwards. So I'm going to take an x out, and then in parentheses, what do I have left? Well, I'll have a 5x here and a plus 2 here. Now notice if I were to multiply this, if I distributed the x, I would get 5x squared plus 2x, which is what I started with. So then with GCF factoring, this would be my answer. On the next problem, notice I have a 3 and a 6. Well, there's a common factor of 3, and I also have a common factor of x. So I can take a 3x out. So then ask yourself, what would I multiply the 3x by to get 3x squared? Well, it'd have to be an x. What would I multiply 3x by to get a 6x? Well, it'd have to be a 2. And so this is my answer in factored form. That's GCF factoring. So another type of method to factor is if it doesn't have a GCF. So what do you do if it doesn't have a GCF? So if, for this example, I have x squared plus x minus 6. By the way, this is called a trinomial because there are 3 terms. X squared is a term, x is a term, and the 6 is a term, separated by plus and minus signs. There is no GCF. So I can't do the GCF method, but I always check that first. If you remember, we talked about diamond problems where you had to find, we had a worksheet where you did these diamond problems and then you had to find products and sums. So we can fill in the x squared. So this x squared is going to get filled in this box. The constant that doesn't have a variable attached gets filled into this box. We're going to use a diamond problem to help us figure out how to fill in the x's. So I need 2 numbers. My numbers need to multiply to a negative 6 and add to a 1, which tells me that my positive number has to have a greater absolute value. So it wouldn't take you long, hopefully, to come up with 3 and negative 2, because 3 times negative 2 is negative 6. 3 plus negative 2 is 1. So that tells me how to fill out the x's, and it doesn't matter where you put the 3x and where you put the negative 2x. I'm going to put the 3x here, the negative 2x here. Now what I'm going to do next is I'm going to look in each row, or you could do columns, and you're going to pull out a GCF. So in this first row, an x squared and an x, I can pull out an x. And then you ask yourself, what do I multiply x by to get x squared? Well, this would have to be an x. What do I multiply x by to get a 3x? Well, I need a positive 3. What do I multiply x by to get a negative 2x? A negative 2. And then check the last box. 3 times negative 2 is negative 6. So my answer, when I'm asked to factor this, I would write x minus 2 times x plus 3. This would be my answer in factored form. If you multiply this together in a box or FOIL it, you'll get x squared plus x minus 6. Now, it doesn't matter if you put the x minus 2 first or if you put the x plus 3 first. That doesn't matter because you're multiplying, and multiplying is commutative, so you can change the order and it won't affect it. So here's another one. So notice if we think about the box, the x squared goes here, the 12 goes here. I'm going to do a diamond problem. This is my product, the 12. My sum is the 7. So I think about the numbers I could multiply together to get 12 and add to get 7. And notice both of them are positive, so my numbers must both be positive. So I get a 4 and a 3. So one of these is a 4x, and again, it doesn't matter which one. And then you look in this row, I can pull out an x, which means this has to be an x, so that when I multiply, I get x squared. This would have to be a plus 4, so when I multiply, I get 4x. This would have to be a plus 3, and I double check the last box. Everything works. So when I factor, I get x plus 3 times x plus 4. Okay, so here's another that's still factoring a trinomial, but if you look at the coefficient of the quadratic term, the x squared is the quadratic term, notice it's not a 1. So we're going to do what's called a modified diamond to fill in the box. Now, we still know this is a 2x squared. The x squared part goes here. The constant goes here. We have to figure out how to break up the x's. But to get the top number, the product, 2 times 4 is 8. So you're going to multiply those two things together for the product. The sum is still just the 9. So I'm looking for two numbers that multiply to 8 and add to 9. So that would be 8 and 1. So then one of these is an 8x. One of these is a 1x. You don't need the 1. You can just put x. Pull out your GCF in the top row. That's going to be a 2x, which means this has to be an x, which means this has to be a plus 4. Again, I'm just making sure I get an 8x there, which means this has to be a plus 1 because x times 1 is x and 4 times 1 is 4, so that works. So my answer is 2x plus 1 times x plus 4. Okay? Next one, first check, is there a GCF? No. So I'm going to do a modified diamond in a box. So I'm going to multiply the 3 and the negative 2. I get negative 6. Here's a negative 5. My two numbers, let's see, we're going to have a negative and a positive. So it looks like negative 6 and a positive 1 will work. We have to fill in the box. Remember the 3x squared we know goes here. The minus 2 we know goes here. These tell me how to break up the x's. I'm going to put the negative 6x here. And we'll put the 1x here. So I'm going to pull out a GCF of 3x, which means this has to be an x, which this has to be a negative 2 because negative 2 times 3x gives me my negative 6x. And this has to be a plus 1. Don't forget to put plus or minus signs where they belong. And so then we get 3x plus 1 times x minus 2. Okay, next one, and notice my note over here, always check for a GCF first. If you look here, I can't take out an x, but I can take out a 2. So my GCF factoring, I'm going to pull a 2 out. I'm going to have x squared plus 4x plus 3. Now, the 2 is going to tag along, but I'm going to do a diamond problem with my x squared plus 4x plus 3. Now, I don't have to do the modified diamond. However, I do want to point out that if I had, remember there's a 1 here, and 1 times 3 is 3, so that's still the product. It's just we don't have to think about it when it's just an x squared. The sum is 4. So my two numbers are going to be 3 and 1. So if I do the box here, we're going to leave the 2 out, and we're just going to have an x squared and the 3 here. And then I'm going to put my 3x and my x where they go. Pull out a GCF in the top row. It's an x. So this has to be an x. This has to be a plus 3. And this has to be a plus 1. And you can double check to make sure it works. So when you write out your answer, don't forget the 2. And then we have an x plus 1. And then we have an x plus 3. So this is what my answer would look like in factored form. You pull the GCF out, then you do a diamond problem with what's left. So here, I start with a GCF. Notice I can pull a 3 out. So when I do, I get x squared minus 3x minus 10. Now, you're going to notice a little shortcut. So here, let me just finish the diamond problem. My two numbers, I know 5 times 2 is 10 and 5 minus 2 is 3, so I must going to be involved with 5 and a 2. I need this to be negative and the 2 to be positive for that to work. Now, if I do the box, which I can, well, let me kind of show you this. Because some of you might just want to stick to that. X squared here, negative 10 here. I'll put a negative 5x here and a 2x here, and then pull out my GCF. And so I get that. So my answer, 3, and then I have x plus 2 and x minus 5. So I want you to notice this. X plus 2, one of them was a 2, x minus 5, one of them was a 5. So if you, those of you who want to, if you skip the box, you can, but only if the coefficient of the x squared is a 1, which it was after we pulled out the 3. Because it won't work if you were doing a problem like this. You have to have the box. If you don't, you'll end up, because notice that when you did the diamond problem, it was a minus 6 and a plus 1, but down here, it's not. So you definitely need to do the box on those. You can skip the box only in that situation if it's just an x squared and there's not a coefficient in front of it. But if you're afraid you might forget that, you can just always do the box, because then that would always work. Okay, so if we try this next one, notice I can't factor out a 4, but I can factor out a 2. So I'm going to do a GCF and factor out a 2, and I'll have 2x squared minus 3x minus 2. Now, that's the GCF step, so you still always do GCF first. But notice that I still have a 2 here. It's not a 1, so I will need a box on this. Let's start with our modified diamond. So I get a negative 4 and a negative 3. So my two numbers are going to be a negative 4 and 1, because if I multiply those, I get negative 4, and if I add them, I get negative 3. We definitely need the box because there's a 2 in front of this x squared. So I'll fill in those. Now I can put the negative 4x here and the 1x here, or just an x. I'm going to factor out a 2x, that's my GCF, which means this is an x, which means this is a minus 2 to make that work, which means this is a plus 1. Negative 2 times 1 is negative 2, so that works. So my answer, don't forget the 2 that we factored out originally, and then we have a 2x plus 1 and an x minus 2. And the order of these factors doesn't really matter. Typically, we put the constant in front, but if you put the x minus 2 and then you had the 2x plus 1, that would be okay. And that was the end of that. So that kind of goes through 3 different types of factoring. One was just GCF that I started with, checking that first. One was doing a diamond problem, and if there's no if there was no if the coefficient to the x squared is just a 1, you could use that shortcut. Or if there's a coefficient that is not a GCF that can be factored out, then you actually have to do the modified diamond to fill in the box. And so hopefully that helps you with how to factor.